Good morning, friends. Myself Shankar Bhanwase, and today we are going to see examples of beta function type 5. In previous video lecture, we have seen the beta examples on beta function of type 1, 2, 3, and 4. In today's lecture, we are going to discuss the examples on beta function of type 5. That is the result integral over 0 to pi by 2 sin theta raised to p cos theta raised to q d theta is equal to, what is the result? Half of beta p plus 1 upon 2 comma q plus 1 upon 2. Okay, let's consider the first example. Evaluate 0 to pi x sin x raised to 5 cos x raised to 4 dx. So there are totally three types of example in this type 5. Okay, first we have considered, that is 0 to pi x sin x raised to 5 cos x raised to 4 dx. Solving this example, we have to use the property of a definite integral, that is 0 to a f of x dx is equal to integral over 0 to a f of a minus x dx. If you replace that x by a minus x, that is upper limit minus x, the value of the integral will not be changed. That is the property. Let's use this property. Let I is equal to 0 to pi minus x. Replace x by pi minus x, sine of pi minus x raised to 5 cos of pi minus x raised to 4. Okay, next 0 to pi sine pi minus x. Sine pi minus 6, it goes to second quadrant, and in second quadrant sine will be positive, therefore sine x raised to 5 remains. Cos of pi minus x again goes to second quadrant, in second quadrant only sine will be positive, then answer as minus cos x, but power is even, that is 4, therefore the value as cos x raised to 4 dx. Okay, I 0 to pi sin x raised to 5 cos x raised to 4 dx. Next, separate the bracket, multiply pi to the sin x and cos x minus x into the sin x into cos x, and we know that by equation 1 the value of the integral 0 to pi x sin x raised to 5 cos x raised to 4 dx is equal to I have written there. Next, take pi constant outside the integral sign. Next, if we shift I on LHS, it will be positive. I plus I is equal to use our type 5th result, the upper limit should be pi by 2, so that we have to, we have to use the property of definite integral. Upper limit integral is multiplied by 2 and upper limit is divided by 2. In this way we can arrange we will make the arrangement of the upper limit as a pi by 2. Integral multiplied by 2, upper limit divided by 2, sin x raised to 5 cos x raised to 4 dx. Now the integral is in standard form. We can use the result. In LHS, I plus I means 2i is equal to 2 pi integral of 0 to pi by 2 sin x raised to 5 cos x raised to 4 dx. Same, 2 to get cancelled, I pi 0 to pi by 2 sin x raised to 5 cos x raised to 4. Use the result. Power of sin theta is nothing but p is equal to 5. Power of cos is nothing but q is equal to 4. Put all these values. Half is with the result, that is pi by 2 beta of 5 plus 1 by 2 4 plus 1 by 2. This is our answer. We can write. If you want to simplify, you can simplify, and the final answer will be 8 pi by 315. Final answer. Similarly, we can consider second example, 0 to pi x sin x raised to 6 cos x raised to 4. Again replace that x by pi minus x, no change in sin x cos x. Next, multiply pi to the bracket and next to the bracket, and put value I, shift to LHS plus I, 2 pi upper limit divided by 2, integral multiplied by 2. Next, compare the value of p and q. P is a power of sine, q is a power of cos. Put the values and try to simplify the answer. Okay, this is example number 2. Next, third example, that is second case, 0 to pi by 6 cos cube 3 theta into sine square 6 theta d theta. Okay, to use the result, we want sine theta cos theta and upper limit is pi by 2. For that, let's start on the given integral as it is. Next, always put the less, that is there are two angles 3 theta and 6 theta, always the less angle. For the less angle we have to put the substitution. The less angle is 3 theta, therefore 3 theta is equal to t. If you put, we get d theta is equal to dt upon 3. Now check the limits. As theta tends to 0, t tends to 0, as theta tends to pi by 6, if you put theta is equal to pi by 6, we get t tends to pi by 2. Now we are getting our limit as 0 to pi by 2. Put 3 theta is equal to t, that is cos t cube. Next, sine square 6 theta means 2 times 3 theta, that is 2t, and the value of d theta dt by 2. Next, 1 by 3 take outside, 0 to pi by 2, cos cube t sine square 2t dt. Again, angle sine theta and cos theta should be there. Here is cos cube t and sine square 2t. Therefore, we have to make the angle same, t and 2t. We know the value of sine 2 theta, that is 2 times sine theta cos theta. Put the value of sine theta cos theta, 2 times sine theta cos theta in the place of sine 2 theta. If you put the value, the whole term square is there, make the square as it is. Next, take square, 2 square outside the integral sign as it is a constant. 2 square integral of 0 to pi by 2 cos cube t first term as it is. Next, sine square t cos square t, squaring sine and cos dt. Next, after simplification, 2 square means it should be 4. I have by mistakenly it is written 8. It should be 2. It should be 4. Okay. Oh, sorry. It is correct. No. It should be 4. Okay. By mistakenly it is written 8. So make the correction. 0 to pi by 2 sine square 2 and cos cube plus here cos square, that is 3 plus 2. That means it becomes 8 by 3, 0 to pi by 2 sine square t cos t raised to 5 dt. Next, it should not be 8 by 3, it should be 4 by 3. Okay, it should be 4 by 3. 0 to pi by 2, p is 2 and q is 5. Put values and simplify. The answer is actually 2 by it is 2. 64 is nothing, it is the 32 by 315. That is the answer. Okay. Similarly, again 0 to pi by 8 cos square 4 theta sine 8 theta raised to 4 d theta. Again the small angle is 4 theta. Make the substitution 4 theta is equal to t. Simplify this one in this way. Next, we will get sine 2t here and put the value of sine 2t as 2 times sine t cos t. Take 2 raised to 4 outside. Again make the simplification, put p and q and we will get the value. Okay, this is the way to solve. One more example is that if the integral is of the form 0 to infinity and denominator contains 1 plus x term, then we have to convert the denominator as 1 plus tan square. Integral, if the value of integral is of the form 0 to infinity, limits are 0 to infinity and lower denominator of that integrand is 1 plus x or 1 plus x square or 1 plus x raised to 4. We have to convert that denominator in terms of 1 plus tan square. It is an important one. Okay. As x power is 4, we have to make the substitution x is equal to tan of root of tan theta. If you take its fourth power, it becomes tan square and our denominator converted into 1 plus tan square. Okay. Therefore, our substitution for 1 plus x raised to 4 is root of tan theta. Root of tan theta. Okay, tan theta raised to half. What will be the derivative? Dx is equal to half tan theta raised to half minus 1 sec square theta. Derivative of tan theta sec square theta d theta. After simplification, 1 upon 2 half minus 1 minus half shifted to denominator. It is root of tan theta d theta. This is the value of dx. Now check the limits. x0 theta tends to 0, x infinity theta tends to pi by 2. Next, I is equal to integral 0 to pi by 2. Our new limits 1 upon 1 plus. As we know, x is equal to, we have considered tan theta raised to half and the whole bracket, the whole term raised to 4 into the value of dx sec square theta 2 times root of tan theta d theta. Again, if you take 4 inside, it is 4 upon 2 for the first term. It becomes 1 plus tan square. That is our adjustment. Next, sec square theta upon 2 times root tan theta d theta. 1 plus tan square means sec square. Sec square cancel 2 times. Take outside that 2. 1 upon 2 outside the integral sign. 0 to pi by 2. Root of sin theta upon cos theta d theta. Okay, half 0 to pi by 2. Next, cos theta shifted to numerator upon root of sin theta. cos theta raised to half, sin theta is in the denominator. If we shift it to numerator, laws of indices, the power will be negative, minus half d theta. Comparing with the result, we get minus half as p power of sine, q power of cos half. Put all these values, original half outside integral sign, and the result half. With the result half is there, half beta p plus 1 upon 2 q plus 1 upon 2. Simplify this one, half 3 by 2. After multiplication, we will get the value. If you simplify this one, gamma 1 by 4, gamma 3 by 4 upon gamma 1 by 4 plus 3 by 4. We know the value of gamma 1 by 4, 3 by 4. At the time of result, we have seen this value, that is root 2 pi. If you put here, root 2 upon 4 pi. Similarly, we can consider one next example 5. Suppose again it is 0 to infinity x upon 1 plus x square raised to 6. Limit is 0 to infinity and denominator contains 1 plus x. Therefore, we have to make such substitution so that the denominator becomes 1 plus tan square. Simple. X in the place of x we have to put tan. Dx is equal to sec square theta. Put the limits. X is equal to tan theta 1 plus tan square. The whole power raised to 6 and the value of dx is sec square d theta. This way we put, and if we do the simplification, if we get sin theta raised to 6, cos theta raised to 4. Comparing the value, we will get the value. Okay. 3 examples are there. The last example is of 0 to infinity 1 plus x. Make the such substitution so that the denominator becomes 1 plus tan square. For if x raised to 4 is there, put x is equal to root tan theta. If x square is there, put x is equal to tan theta. And if it is x there only, then we have to put x is equal to tan square. Okay. And next angle 4 theta, 8 theta, 6, 3 theta, 6 theta is there. For the smaller angle, we have to make the substitution and we have to use the result of sine 2 theta. This is type 2. And what is the type 1? It is x minus sin x power and cos x power, and the upper limit is pi. In that case, we have to use the property. We have to replace x by pi minus x, multiplication I plus I 2i, upper limit and lower upper limit divided by 2, integral multiplied by 2 property, and next the result. In this way, you can solve these examples of beta function of type 5. Okay. Thank you.